Did it? What'd you get for the train problem? That was the first one, right?
I got 87 for A and B.
Yeah, I got 87.
I got 87 also.
Okay.
Nice.
Yay.
Y'all get 87?
And then you get 94.
You get 87 also for right?
Yeah, you get it.
Because, where'd it go?
I don't know.
Notice the first one, the first interval is 0, and then the last one is 0. So then left and right doesn't matter, because if you do it on the left, you're on 0. If you do it on the right, you're on 0 in the first one anyway, so it doesn't matter. That's why we do the same thing. And then what'd you get? 90 what?
4.
Yep, 94.
How do you know?
I got 80.
Because it's in the,
It's in the middle, so I just drew, like, I didn't draw the actual picture.
neither, I was just trying to. I mean,
Oh, the table? Yeah, but I just, for that one, I had to draw a little sketch, because I was like, which one do I use? Well, with 5 intervals, I was like, see, these aren't accurate at all. I didn't actually graph it. I just set it up 1 through 10, put my 5 boxes, and went, okay, in the middle of that box is 1, in the middle of that box is 3. So just to know where the midpoints were.
And you multiply by 2.
Yeah, and you multiply by 2 because the base of each rectangle is 2. Did you get that one?
I got 80.
You got 80?
Why did you use only those numbers and not all of them like the rest?
Because it
says
said
the
5
first.
subintervals. So that means your rectangles are going to be wider, because you're only going to have 5. And it's, well, it says of length 2. So then you make the rectangles wider and use the midpoint. So in the middle of the first rectangle is the value of 1. So I just used the y value from t equals 1 there, and then 3, 5, 7, and 9. Those are the y values for 3, 5, 7, and 9. This one was crazy.
The next one?
You could have used a calculator, I didn't tell you that. I started doing it without a calculator, I was like, man, this
Yeah.
I did it just to get like the actual
is
numbers.
ridiculous. Yeah, so your picture should look like that.
Yeah.
Oh, I didn't draw that. So then the left approximation, 11 fourths, which is 2.75. Yeah. 23 fourths, which is 5.75. And then 31 eighths,
Man.
3.875.
I guess I really messed up there.
I thought you just read it down.
No.
Because I
That's
got
me.
5
I was gonna
squared
text you,
5
but then I
and
forgot.
11.5 and
So I was too busy talking about
7.75.
this for like 2 hours.
Did you divide by half?
Yeah, did you do halves?
So you gonna
I
You going?
don't think
Because,
so.
right, it said to do 4
Yeah,
subintervals, and you're only going from 0 to 2, so each rectangle is only half wide, so it's half for the base times the height. And then you have all those ugly numbers.
Is that the- Yeah, I forgot to multiply them by half.
What did you guys do? Did you get that one?
No.
What happened?
I don't know.
Oh, man. I remember doing it and I did not do that.
Did you get decimals? You use decimals.
Yeah, I got decimals.
I know.
That's fine. Are they the correct ones?
4, 8, 12, 16, 20. B is.
Good. Any questions as to how I got these things? Remember the left one, you just, on each,
You start.
you
from
start on the left,
go
so
to
I'm
the
going to
right.
use that for my height, that for my height, that for my height, and that for my height, and I don't use that last one. Because my last rectangle, if I actually drew it, would just be right there. And I'd have no rectangle over here. But if you do the right approximation, and for each rectangle, you go to the right. So you got there, 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 and there, so you would use that one. Makes sense? And then midpoint, that's the one I busted out the calculator. I was like, I'm not doing it. That again, like 1/4, plug it in. Use your table.
No.
Ah, see, I was like, I wonder if they'll
Oh,
realize.
yeah, I used the table.
Oh, good, that was smart. Instead of plugging in 1/4 so many times, you just plug that in for y equals.
I just set up my
Set
table.
your table to go by 1/4,
Yeah,
and then
1/4.
use all the numbers on the table. Good. That's a good speed tip.
That's what I did.
Let's see. One more, right?
Yeah.
What'd you get?
1548.
Oh,
Oh, that's not what
You got 1548 too?
Yeah.
I might have done it wrong. I don't know.
You did it wrong.
What's the number?
The first one,
I didn't sleep last night.
you should have started with 30
Yeah, you should start with 30.
Yeah,
Why?
that's what I got too.
Because it says.
because you start from the left.
Oh, I did right first.
Oh,
There you go.
I got 1512.
Yeah.
Left, I got 1548.
Yeah.
Okay, but
For right, I got 1512.
Yeah, that's what I got too.
All of y'all got 1512. Let's draw it. Anyone got a picture?
No, my picture's ugly
Not a good one.
No, a good one.
because I have like all three. I have
They're all 12 wide, right?
Yeah.
12, 2, 3, 4, 5, 24, 36, 60 to 27. I'm just going to pick the numbers. 24, 22, 25, 28, 30. That, right?
Yeah.
So which one do we not agree on? Right?
Right.
So to the right, on this one, I go up to 28. 12 wide times 28. I'd go up to 25. I'd go up to 22, 24, 27.
I have it written down exactly the same.
Yeah.
My answer
Yeah.
is the same.
I did it in my head,
So you probably messed
so I
up.
could have been wrong. 28 plus, that's probably it.
126.
Yeah, you're right.
1872.
Dang.
Barrett decided he didn't want to sleep last night. He's tired. I did this morning. Oh,
So did I.
good job for correcting me. Why can't you do the midpoint on this one?
I just said because you don't have an equation. I don't know if that's right.
Good answer. There's also other answers. Anyone else answer that? You just did A and then stopped.
Maybe.
Because they're like,
Sounds about right.
why can't you do the midpoint? Well, if I go in here, do I know what this is?
No.
No. It doesn't give you an equation, so you can't like graph it and plug in points. And it doesn't give you the values for when t equals 6, so you can't do it. That's it. That was it. I wrote. Need y values for t equal to 6, 18. Right? You just need all the ones in the middle. We don't have that.
That was a success.
Huh?
That was a success.
Good.
For once.
Easy stuff, right?
Don't be saying that.
Until, no, today will be easy.
We're gonna start doing that trapezoid thing.
Trapezoid thing. We are going to do the trapezoid thing after I tell you about integral notation. We could write all of these in integral notation. Didn't I show you what it looked like and it didn't explain it yet?
Yeah.
So the way it looks, it's like a weird S thing. Like that. That's the symbol for an integral.
What's the Sephora?
A what?
Sephora?
Oh.
It's like a.
Beauty product.
Yeah.
Yeah.
And then there are, most of the time, a definite integral, which we'll get into definite versus indefinite later, but for now, just, there will most likely be numbers here, written at the bottom of the little s thing and at the top of the little s thing. And then there will be a function, and then there will be d something, in this case dx.
You don't put equal.
No, it's not an equation.
Okay.
This will equal something, and then whatever it equals will be the area under the curve there. I'll explain that more. So these all have names. That A is called the lower limit of integration. What do you think the B is called? I bet you can guess.
Higher.
Higher limit
Upper
of.
limit, yeah.
Oh.
Yeah, that's the upper limit. The function that you're integrating is known as the integrand. You won't hear that used very much. That's what it's called, but I don't think I've ever seen it referenced as that in a problem. And then the dx is the variable of integration. It's like when we do derivatives and I'd say with respect to x, it's kind of the same thing. It's just it's the variable you're integrating. So the way you read that would be the integral of f of x from a to b is whatever. Let me write that down.
No.
You'll get used to it. We'll say it so many times, you'll know how to read it. So, the stuff you did last night, for example, like I could do any of, well, this one, let's say. The one with the function. We approximated the area under the curve from 0 to 2, right? So the way you would write that as an integral would be the integral from 0 to 2. That's the lower limit. That was the upper limit. We didn't keep going. The function keeps going, but we didn't. We just wanted the area under that piece. And then you would put your function, x to the third minus x plus 1. And then you'd put dx. And that equals, depending on how you do it, it could be 11/4, 23/4, or 31/8. Which these are just approximations. Remember that's what that stands for? Rectangular approximation method. If you actually do the method of an integral, which hopefully we'll get to by the end of class, you're going to get the exact answer. Which those are just, so you're going to get some answer, and that answer will represent the area under the curve from 0 to 2.
So when we do it that way, we won't have to do it the other way?
The rectangle way?
Yeah.
Yeah, that's nice. But you might find this is easier sometimes, depending on the function. This function would not be hard to integrate. Integrate is the process of doing the integral, kind of like derivative. What was the word we always say? Differentiable. What's that mean? The ability to do the derivative. Okay, so let's do one with a trapezoid rule. So we're going to evaluate. I just showed you that. That way we can do the trapezoid rule, but we're going to just use this notation. So it's just a different way of writing it. Using trapezoid. Approximation. Trapezoidal, yeah, that's a good word, huh?
Beautiful.
I forgot I was going to show you how to do this on a calculator. Do that tomorrow. Do it by hand first. Okay, what's that mean we're going to do? In your own words.
And
Function x squared.
You're going to look at the function x squared from 1 to 5. And use trapezoids to
Find the area.
find the area under the curve. So this should be pretty easy to graph, right? Just good old x squared. What's that look like? Parabola, vertex is 0, 0. Something like that, right? Side effects are necessary. 1, 2. Think you could do this on your own just off the 10 seconds that I showed you yesterday, just as an intro?
No.
Yeah.
So remember, on this one now, we're not using rectangles. We're going to use trapezoids because it's more accurate. Well, they're like sideways trapezoids, right? Let me end up now. So if we draw that, picture's nice on this one. That makes it easier to see. So,
Like it followed it exactly.
yeah. Point, point, not exact.
Oh, you can do that now?
What?
Start at 0 and 0.
Yeah, you can start at 0 because the trapezoid, it almost makes a triangle. It does make a triangle. So we'll have all of these. Like that. That's pretty accurate. Will that be an over approximation or under? Over.
Just a little bit.
Because they all go over. And actually, just a little trick. If the function is concave up, you'll get an over approximation. If it was concave down, so if it was like
Under.
and you do it, you'll get under approximations. Usually smart ball. Yeah. Because they'll all be slightly under. When you connect, because it'll be a little bit down, so when you connect the 2 points, it'll just be a little bit under. Okay, how do we find the area of trapezoid? You remember?
1/2 base 1 plus base 2. Height times height
Yeah, height,
times.
base 1 plus base 2. So would you like to write that? Oh, wait a second, I messed up.
Of course, no.
I'm just kidding.
You did too. Let me see a picture. Did you copy mine?
No,
Maybe.
What's that mean?
you can't go below.
Yeah, we don't care. We don't need that trapezoid. We're just going from 1 to 5. We just want this area. We don't want that piece, so I didn't draw that one.
Whoops.
Whoops. Yeah. Just got so used to doing it. Because yesterday all we did was from 0
Yeah.
0 to whatever. So this one, yeah, just 1 to 5. So now, would you like to write the area for each one individually, or do the shortcut way? Shortcut way? Yeah, I like it. Because they're all going to have the same height, aren't they? And they're all going to have the half. So, the way we can write this officially would
Wait,
be,
The height would be different.
The height is tilted, right? It's the x-axis.
the height is this way. Remember all these trapezoids?
Yeah, so it'll be all one.
Are
Oh, okay, yeah. Okay. So it'd be
Yeah, because
one.
otherwise you'd have 2 different heights, and that doesn't make sense. The bases are different lengths. That's base 1 and base 2. But the height is this way. So our integral from 1 to 5 of x squared dx will equal, they'll all have half, they'll all have a height of 1. So using the shortcut way, what's going to go in there? You're only going to use 1 once, right? That base of that trapezoid just gets used once.
Yeah.
So you're doing 1. Oh, is it 1?
Oh, yeah.
Yeah, remember we got to do y
'cause
values.
x squared.
We want the length of that. If our function is x squared,
1 times
should we
1.
write the y values just to make it easier? The y value of that point will be 1. What's that one?
4, 9,
Putting in.
16,
I
25.
know, I keep wanting to do like 1, because it's,
Yeah.
Keep wanting to do what?
I keep wanting to be like, oh, that's, since Alvin's 1, that's like a little over. I forget to like,
Use the
like,
function.
yeah, like what you actually just do. Look at the. Don't assume. Yeah.
Yeah. Use the function. Plug in 1, 2, 3, 4, 5. Those are my y values. Okay, so you only use 1 once. Plus, but remember, this base right here
You're gonna use it
gets
twice.
used in this trapezoid, and it gets used in this trapezoid.
So 4 times 2.
Yeah, 2 times 4, 4 times 2. Once you do enough of these, you realize that all the middle ones get used twice, and the outside ones get used once. And so it becomes really fast just to go through it. You see that? How that one's going to get used twice, that one's going to get used twice, that one's going to get used twice, and that one gets used once. So can you finish writing your expression here? Try it. Try it and calculate it, see what you get. This, I was preparing to multiply this by 2. I just stopped. See if you can finish. Let's see what you get. No, it says it.
2 times 16 is 32.
Schooling today.
8. 8 plus that 25 is 84.
No, it's not. I did something wrong.
Oh, yep.
Come on.
Told you I'm off my game today.
Someone didn't get enough sleep.
Raw, what'd you get?
42.
Half of 84 is 42?
Yeah. Yep. Yep.
Must be those lucky
Oh,
charms
yeah.
state.
I did 2 times 25. So not smart.
Rookie mistake.
What was it?
Why did I
Surprised all of us
do?
didn't do that.
I know. Katie, did you do 2 times 25? Did you get 54.5?
I did.
I didn't even.
Good answer. That's the good wrong answer. It's wrong though. You used 2 4s, 2 9s, 2 16s, only 1 25 though. So when you add those all up, you get 84, half of 84 is 45. Yeah. Did you get it, Tanya? Alright. So you'll have to do some trapezoid ones in your homework. That's that.
Oh, I don't know. Hey, does golf have a match today?
We got extra time. You want to see how to do this on your calculator?
No.
Sure.
Check this out. Let's get the actual answer. Remember, that's just the trapezoidal approximation. So the actual integral, I'm not going to show you how to do that until tomorrow. I'll show you how to do it on your calculator right now. So, remember what was it called? N deriv? Yeah. There's another one right below it.
Someone stole my calculator.
Can't see it. Can't see it. There it is. You hold it right in the same spot. Right below n deriv is fn int. Yeah, so you're going to do the fn integral. It stands for function, actually.
Say hi.
You're going to be on TV. You're going right here. Oh, great.
Someone stole mine.
So it's the same format, the way you type it in.
Do you want?
Someone stole your calculator, really?
I don't know. Someone, yeah, I left it in Mrs. West. Have to go find it.
Sounds more like your mouse stick.
So you remember in n deriv, you had to put
Whoa.
Your n deriv, your function, comma, with respect to x, comma, and then if you wanted to do it at a certain number, you'd put the number, or if you wanted to do it on the graph, you would just put x. This is like the same thing, except you're using the integral one.
Question.
So we would do fnint. You don't have to put your function into y1 and then do the whole vars thing. You don't have to do that. You can literally just put your function like that. If you're going to do this multiple times, it might be easier to do it as y equals and then use y1, or if you have multiple functions. But if you're just doing it one time, you can do that. You know what I'm talking about? Like, remember we used to go like this? Y equals, and then we would put x squared. So then we'd go math, FNIT, and then you had to do the vars, function, y1. That just uses whatever you typed into y1 to evaluate the integral. So it's just the same as if we just go, oops, that x squared, comma, see if I remember how to do this. With respect to x, and then the interval, I think we just put 1 comma 5.
How do you do the comma?
It's right above the 7.
Oh.
Hopefully. Right. Yes.
Yeah.
Yep. So you just put 1. So you're going to have 4 things in there. You have your integrand, or your function. You have the variable, which you're integrating with respect to, in this case with respect to x. And then you put your limits of integration. So like in this one, we're going from 1 to 5. So we put 1 comma 5. Close the parenthesis, hit enter. So the actual answer is 41.33333, 41 and a third. Pretty close. Our trapezoidal approximation was pretty close.
Yeah.
And it's a little bit over. Hey, that's what we thought, right?
Mm-hmm.
So this is a good way to check your answers.
Or just
Oh,
leave it in the
geez.
beginning.
No, Heidi. No.
Bad Heidi.
Okay, last thing.
You were saying the same
Or
thing.
she.
Great, now it's-
No, because then if it asks for an approximation and then you give the exact answer.
Mhm. I'm
Nope.
just gonna round it up.
Imagine we write big old test.
If it's like concave up round.
We're gonna play games.
You show us these tricks.
I'm like, I love
Do
it.
Remember, Brenda looked up the the last year's AP test, and this was on. It had a trapezoid. Was it trapezoid? It had a trapezoidal approximation on there.
That was hard.
Integrals of constants.
I can understand.
Well, now you will.
This you're actually going to do by hand.
No.
Oh, well, you can do it. Let's see if it works. There she is.
Skip my
Oh, sorry.
Sorry.
Can you do that to him?
Remember the train problem?
The what?
Train problem.
Yeah.
Yesterday, our elementary school problem.
Yeah.
A train is going 75 miles per hour
Oh, yeah.
from 7 p.m. to 9 p.m. How far did it go?
Okay.
Let's do that using an integral. We know the answer, but let's see how you would do it using an integral. Because remember, we graphed it and we just found the area under the curve. This is the same thing. So for that train problem, what would our function be that we would be using? Remember, I told you it was going, how fast? 75 miles per hour from 7
To 9.
to 9, doesn't matter what.
7
9
a.m. to 9
9
a.m.
a.m. Then we figured out how far. Really easy answer, but there's a whole bunch of different ways to do it. And we graphed it, right? We graphed the velocity function versus time. Which in this case, if it was like 1, 2, 3, 4, 5, 6. The question is, what would your function be?
75.
75.
Yeah, y equals
X.
75. The PFT is just 75. The speed didn't change. It was just constant. And all we're looking at is from 7 to 9. So can you write that as an integral?
As a what?
Integral. Try it. What'd you get? What'd you put here?
7.
To 9?
Yeah.
9.
What's your function?
75.
If you list V of t up here, you could put V of t right here, or you could just write this part, it doesn't matter. 75 d.
dx.
T.
You could argue for x, but I like t in this case because times. Whatever your independent variable is, you can use x or t. So that's how you would write it. Hey, let's try it in the calculator and see if it gives us the right answer. And then I'll show you how to do it by hand. This is going to be the first one you're actually going to do by hand. We'll get to the complicated ones next week, because they get plenty complicated.
Mhm.
You get it?
Yep.
You just
Wait.
type that.
Yep.
Your function is 75, no variable, because it's just a constant. With respect to x, because there's no t, from 7 to 9, boom, it gives you 150. Hey, that's what we wanted. Hey, how do you think it would change if I put 9 or 4 to 6?
No.
Same answer.
Yeah.
Yeah, because it's still 2 hours. Yeah, all right.
Yeah.
So here's how you do it by hand. Remember when we learned antiderivatives?
Wait, is there such thing as the derivative of a limit?
Derivative of a, no.
Okay.
You use the idea of a limit to do the derivative.
Finally.
Because remember, you want me to go into this? This is
No.
good. Yeah, this is good. Oh, God.
Because I was reading a problem and I don't know.
How far?
Limits are the idea of some number approaching something else, right?
Mm-hmm.
Well, a derivative is a slope at a point. So what we did was, we said, here's a point. Well, I can't find the slope at a point. I have to find the slope between 2 points, right?
Yeah.
So we picked some point over here, and then we moved that point as close as possible to the other point. Remember that? Like if this was x, this would be x plus h. And we did the limit as h approaches 0, because h was the distance between those. So we wanted the distance between those to go as small as possible and get close to 0. And then we did the slope. We did the rise would be f, that would be f of x, that would be f of x plus h, right?
Yeah.
So we did rise over run, so we did y minus y over x minus x. Remember that? That is the derivative. Later we learned all those little tricks, like if I do x squared, the derivative of that is 2x. But in the very beginning, I made you do that whole thing and do the limit as h approaches 0 of f of x squared plus h minus f of x squared. You did that. You can do derivatives by hand. So derivatives use the idea of a limit to get slopes at points. The derivative would not exist without limits. Okay. So integrals, we could talk about why this works, or I could just tell you. Integrals are antiderivatives. It's going backwards. So when you do this, the integral of the function, what is the antiderivative of the function 75?
75x.
75x or t or whatever you're using, right? So you do 75t, that's my antiderivative. You don't have to worry about the plus c.
Why?
Good question. I thought about that earlier too when I was coming up with this. It's like, why don't we have to worry about the plus c? And I don't have an answer for you right now. But after we're done, maybe I'll think about it. It's gonna, but as you saw earlier, my brain is not functioning at full capacity today.
So it might be a wrong answer.
So what you do then, you do the antiderivative, and then you put a little line right here, and then you put your limits right here. And then what this means is, I'm going to plug in 9 for t, and I'm going to subtract, plugging in 7 for t, And that will give me my answer.
This is so good.
Do 75 times 9 minus 75 times 7, I bet you get 150.
Yes.
Yep.
That's how you do integrals by hand. Why that works.
It's magic.
Well, this,
Wait, that's how many he tried. Wait, what was
That's how far the train traveled
That's how far
from
the train
7 to
traveled.
9.
because if your velocity is constantly 75, your position is just 75 times t. So that's a line with a slope of 75. And so if I just plug in points, if I plug in t equals 9, that'll give me my position at 9 hours, or 9 times 9. And then if I do my position at 7 hours and I subtract my position, doesn't that tell me how far I've gone?
Yeah.
You plug in 9,
Hamburger, junior pods, cowboy beans,
that'd be like,
green grapes,
Okay.
and cookie.
So mean, dude.
You asked
so that's
me
what, and
always
then we
for
subtract
lunch.
those and you get 150 because I
I
went.
just wanted the main course.
It's not the area under this curve, it's the area under this curve, which happens to be the difference in the y values on the So just another one, because this is part of your homework. I'm gonna give you a homework-like
You're so
problem.
dumb. I didn't even touch it. I just wanted. Did you even put it in front of the camera? I did.
What do you mean?
You can't even see it. You see my fingers?
Oh, wow.
Yeah.
Wait,
So
can we
this
use
is a
a
homework
calculator
problem, it'll
for
say
this?
evaluate the integral. So it just means figure out what that equals. So what do you do? What's the antiderivative of 0.5?
0.5x.
0.5x, and then you're going to do it from negative 2.1 to 3.4. So you plug that in for x. So you'd have 0.5 times 3.4 minus, and then you plug that in for x, 0.5 times negative 2.1.
You do the top one first, or does it matter?
Yes, it matters. Top
The
one
top
first.
one
It's
first.
always top minus bottom.
Don't say the answer yet. Oh, negative.
2.75. And watch it. Let's make sure. Let's check our answer. Let's FNI and T it.
FNINT, yeah.
FNI and T 0.5. FNI and T it. Well, we still get 2.75. Magic. That's it. Hey, we got 5 minutes. I might as well show you how to do.
No.
Like to do that one.
Sad no.
To do that one by hand, it's the same process. We didn't do this by hand, but watch. 1 to 5 x squared dx equals, what's the antiderivative of x squared?
X to the third. No,
X.
X.
It is x to the third, but what do you need?
1/3.
1/3 x to the third.
That sucks.
That's the antiderivative, and we're going to do that 5 to 1. So if I plug those in,
So 1/3.
5 to the third is 125
Whoa.
thirds.
Mhm.
5 to the third is 125 times the third, 125 thirds. Minus, Plug in 1 to the third is 1,
Three.
that's a third. So 125 thirds minus 1/3 is 124 thirds. 124 divided by 3 is not 40. Oh, that was an approximation.
It's 41.3.
It's 41 point, oh yeah, it's 41.33333. That's what we got.
Yeah.
Add two.
I think I might have a shot at this.
That's all integrals are. Do the antiderivative, and then plug in that, and then plug in that, and subtract them. That's doing integrals.
It might have a chance.
You got my
There's a chance.
I should know where that one's from.
Where's it from?
Mr. Hopkins, I
Alright.
didn't get the same thing on the calculator as that one.
Let's see. So we just did section 6.2 and part of 6.5. We didn't even know it.
I hate that you put number sign.
In front of Q, R.
I don't know why it bothers me doing this.
There, just for you. You want it after QR number?
Oh my god, no.
QR number.
Actually, I did that.
Big for the Spaniards.
I
Felt
got
like-
negative
felt like that was a good day.
2 point-
You could stop it.
I got negative 2 point.
0.5 is x, 3.4,